All the hypothesis testing we did in Chapter 10 only involved one set of data. And the sections we're covering in Chapter 11, we're actually going to be comparing two different sets of data and trying to make some kind of conclusion about those two sets. All right, so we still have the criteria that we need to work with here. Today we're focusing on matched pairs data. It's been a while. Do you guys remember what matched pairs data is? Matched pairs data was like in our very first unit. It was data that was related in some way. So maybe I have you take a pre-test, and then I study with you, and then I give you a post-test, and I compare your score on the two tests. It's matched pairs because your two scores, they're both yours. They're related in some way. Or maybe I have a survey and I have a husband and a wife take the survey. So they're paired up in some way. So we're comparing data from maybe two different people, maybe the same person, but they're connected in some sort of way. So our criteria, we have to have a random sample, we have to have matched pairs. The main one that we need to focus on, normally distributed or n greater than 30, and they have to be independent. So when I ask you to check criteria, we're talking about means or proportions and everything we're doing with this chapter as well. Today we're focusing specifically on the means, so we know that anytime we're talking about a mu, then our sample has to be bigger than 30, and we've used that for a while now. So the difference in our hypothesis testing, we still have left-tailed, right-tailed, and two-tailed tests, but in these, instead of using just a regular mean, it'll say mu sub d. That's the mean of the difference. So what I'm going to do is take two scores, and I'm going to find the difference between them. So I had your pre-test and your post-test, and I'm going to look at the difference. So I'll take those two sets of data, subtract them to get a single set of data that then we do all the stuff we were doing in Chapter 10 with. So we'll get our hypothesis and our t-statistic and probability and all of that. So we'll have to have our hypothesis, we have to know our alpha. We'll compute this test statistic, the t, which is like what we were doing before, difference. This says d bar and f sub d. That's just meaning the mean of the difference and standard deviation of the difference. So we're going to look at the difference between the data. And then we can do either the, we've talked about like using the critical values and working on the calculator. Chapter 11, we are going to pretty much do everything on our calculator because it's going to be more time efficient, and in Chapter 10, I already had you practice doing these tests by hand. So for this week, we'll pretty much do everything on our calculator. And then, of course, you have to write your conclusion at the end. Okay, so I talked through a couple different ways, but we'll really just look at our calculator because we're going to have actual sets of data sometimes to look at. So here is our first problem. So the data represents the cost of a one-night stay in a Hampton Inn hotel versus a La Quinta Inn hotel for a random sample of 10 cities. Test the claim that Hampton Inn hotels are priced differently than La Quinta hotels at the alpha equals 0.05 level of significance. All right, so anytime we're going to do this, we have to have our null and alternative hypothesis, and we have to check our criteria before we do much else. The null. Okay, I just want to know if they're priced differently. I didn't specifically say if this was a mean or not, but my two options are really, is it a mean or a proportion? We know if something's a proportion, it has to be a percent, right? So these are clearly not percent, so we'll be looking at the mean. Why are these matched pairs data? Yep. So we're going to look at the mean of the difference. And so if these are the same, what would be the difference between them? 0. So our null hypothesis is that the difference is 0. The alternative hypothesis, I want to see if they're different, so that would be not equal to 0. So far, so good? Let's use our calculator. So we are going to put the Hampton Inn in L1 and La Quinta Inn in L2. It is important to put these in order because I need, these are related, so the first one has to be the same in both. Now, when we have matched pairs data, we don't actually want to look at these things individually. We want to focus on the difference between the two. So difference is what operation? Subtraction. So what we have to do is go through and subtract them. Now we can do it all by hand. We can say, okay, 129 minus 105, and then we're going to put these in L3. The easier option is go up on top of your L3. So I have L3 highlighted, and you notice at the bottom it says L3 equals. I'm going to make it L1, so if you hit second and 1, that's L1, minus L2, so second number 2. So at the bottom it says L3 equals, and I did L1 minus L2. If you hit enter, it will automatically subtract all of those for you, and you don't have to go through and find all the differences yourself. Did everybody get that before? So now we are really doing the same thing that we were doing in the last section, but we're going to run all of our tests on that L3 because that's where my difference is. So we need to go to Stat, Tests, and when we were talking about the mean, do you guys remember which test we did? Number 2, the t-test. So Stat test number 2. All right, do I want it off data or stats? Data. We just entered everything in data. But it says the mu of the null hypothesis. What is the mean of my null hypothesis? 0. And lists. Which list do I want to calculate everything? L3. So second number 3 would change that to L3. And my alternative is not equal to, so then we can just go down to calculate. So then it gives me t equals 5.27. The probability, 5.128, but it has e to the negative 4, so you move your decimal back 4 places. Okay. So when do we reject? We reject if p is less than alpha. Okay, my alpha was 0.05, so P is smaller than alpha, we reject the null hypothesis. Okay, that means there is enough evidence to conclude the hotels are priced differently. Would you guys, if we wanted to do this by hand, would it be okay if I walk through how to do it by hand? If you don't want to write it down, that's okay, but I just want to kind of show you that by hand we get the same thing. I know there's a couple people that do kind of like to work them out by hand, and I'm not taking that option away from you. I'm not going to require you to use the calculator. If you wanted to do it by hand, you still will have to use your calculator to get the difference. And then if you went into the calculator, so we know we can calculate one variable statistics, we would have to do that for L3. And what we're going to need is the mean and the standard deviation. So my X bar here is 51.4. That's the mean of the difference. The standard deviation of the difference is 30.8336. So then we know we get our t value. And so your t is your mean divided by the standard deviation over the square root of n. How many did we have here? So if I calculate that, you get 5.27, and that's slightly different than what our calculator gave us. The calculator said 5.12, but we're pretty close. And then we would have to use the table to get our t statistic. So our critical value, we knew that alpha was 0.05 in this problem. If you look at your t distribution, alpha is 0.05, but we're splitting it up into two tails because it was a two-tailed test. So 0.05 divided by 2 would be 0.025. My degrees of freedom, n minus 1, would be 9. So you go to 9 and 0.025, and that gives us 2.262. So this would be a negative. So that anything in the shaded region would make you reject. We know it's centered at 0. So would 5.27 be in the shaded area? Yes. So in that case, we still reject. So you can still do it by hand. Since we're already using the calculator to get the difference anyway, it's easy to go ahead and do the whole test there, but you are not required to. You have all those options available to you. One thing that could potentially create some issues, when you subtract two numbers, does order matter? Yes. So typically, we'll just do the first thing is L1, the second thing is L2, and then the difference, we'll just do the first minus the second, just so that we're all the same. You can do it the other way. It's not going to be wrong necessarily, but you have to interpret your answer. So if I were wanting to check if Hampton Inn was more expensive, what would my alternative hypothesis be? Yeah, if this one's more expensive, then when I subtract them, I should get a positive. So my difference would be greater than 0. If I wanted to check if Hampton was cheaper, then my alternative would be less than, because if the first one is smaller, you get a negative when you subtract them. Does that make sense to everyone? So you kind of have to think on your null hypothesis. If you want one to be higher than the other, does that mean less than or greater than? We've also tested these kinds of things with confidence intervals, and so that option is still available to us. So as far as creating the confidence interval, it's the same as what we've done before, except everything has to be based off the difference. So we're used to doing the mean plus and minus the t-statistic times standard deviation over square root of n. The only difference here is that the mean and standard deviation I use has to be for my difference, for when I subtract those two things. So let's look at a problem for that. So if I wanted a 90% confidence interval for the difference between those prices. So we could certainly do it by hand, and I can show you that in a minute if you want. On the calculator, do you guys remember what we went to get the confidence interval? Stat, test, and we need number 8, a t-interval. Okay, so it's going to ask you if it's based off data or stats. We have everything entered as data. My list is bringing up that L3, the difference. Confidence level, I wanted 90. So when I calculate, so remember when we're trying to decide if we reject or not, we look at our null hypothesis. The null hypothesis was the difference was 0. We are 90% confident the true difference is between $33.53 and $69.27. Is 0 in that interval? No. 0 is not in the interval. We reject the null hypothesis. There is evidence the means are different. I want to do you want me to show you how to do this confidence interval by hand? Does anyone want to see that? You're good? Trust this? Okay. Let's do one problem. Sorry, I didn't type it. I was just going to pull it out of the book, but I realized you guys haven't been bringing your books. So let me jot this right here for you. I did include some blank slides, didn't I? Yeah. All right, so we are going to look at comparing. It's a common held belief that SUVs are safer than cars. If an SUV and a car are in a collision, does the SUV sustain less damage? So we have an insurance institute that took into account different accidents. So they have different types of vehicles And we're looking at accidents where one was an SUV and one was a car. Okay, so this is the data. I'm going to abbreviate this. Well, actually, let me do this. All right, so we are going to take some of this data here. We are going to put the SUV as our L1, the car as our L2. What would L3 be? Okay. So go ahead and do that for me. Make sure you're clearing your list, not deleting them. Remember, to get it to subtract, you go up onto L3 and just do L1 minus L2, enter. Okay, so first question, why is this matched pairs? We have two different...
Because they got into a car together.
Right, they were in an accident together. They were in the same accident. Sorry, some of these are hard to read. We need to write our null and alternative hypothesis before we can do anything. So the null hypothesis, since it's matched pairs, we're looking at the mean of the difference, and that's always going to be equal to 0. We're going to assume there is no difference to start us off. Then the alternative. Okay, we have to read what it's asking here. So it wants to know, does the SUV sustain less damage? So we did SUV minus car. If the SUV had less damage, what would my alternative be? Less than 0. If the SUV is smaller, then you should get a negative when you subtract them. Okay, so then if we wanted to test this, we go to stat, test, which one do we want? Number 2, a t-test. We're running it off data again. We need to make sure the difference is 0 and the list is L3 because that was our difference list. And we are testing less than. Calculate. So our t is 0.7126. Sorry, 0.7128. The probability of that was 0.7486. What?
I think
a lot of us got
Did I
that.
mistype something?
Yes.
Corrected. So the probability of that, 0.0181. So we know we reject if P is less than alpha. Let's assume alpha is 0.05. So do we reject or fail to reject? Reject. P is less than alpha. Reject the null hypothesis. There is enough evidence to conclude SUVs have less damage. Okay. Any questions for me? Okay, so that is it for 11.2. Here is what I'm going to do. I have the packet for 11.2 and 11.3. Those are the two sections I'm teaching. I'm going to go ahead and do 11.3 tomorrow because Wednesday I'm going to be gone for a conference. So you will have a work day on Wednesday.
Do you know who the sub is?
Miss Jetty.
She always wants to put her hands on me and stuff. She thinks I like her. She really did.